Today we are doing our last lesson for Unit 3, and we're going to bring everything together that we've learned about circumference and area, and today's lesson is about distinguishing between the two, deciding which one is going to be appropriate to use in solving a problem. So we're going to be using those formulas that we have for circumference and area. Those are still going to be very important, but now it's going to be using our understanding of what circumference and area are to decide what would be needed for each problem. If we look at the first one here, this is meant to be a card sort activity where we would sort them into different groups, and we're doing that a little bit differently here, but we're going to look at the 8 different questions and decide if that should be solved by calculating the area of the circle involved in the problem or calculating the circumference of the circle involved. So for the first one, it says how much fabric is needed for a round tablecloth. Now, before we go any further, let's quickly review. If we have a circle, remember the circumference is talking about that distance around the outside edge. That's circumference. If we're talking about the amount of space it takes up, the amount of surface area it takes up, then we're talking about area. So keep that in mind as we look at this. So how much fabric is needed for a round tablecloth? Well, obviously we need to cover the entire table, so we're not just talking about the circumference around the table, we want the whole area of the table. So that would go down here in solving with area. All right, number 2, how fast do you go when riding on a Ferris wheel? Well, we would need to think about, this is a rotating wheel, kind of like a bike wheel, and we had several questions like that. How far are you traveling with each rotation? In that, we were finding the circumference. So that would be an example for circumference. Now, I do want you to go ahead and look through the rest of these. Go ahead and place them in the appropriate boxes where you believe they would belong, and then we will continue talking about it. So next it says, for 3, how much green space is there inside a traffic roundabout? That word inside is a key to the idea that we are talking about area here. 4 says how many square inches of cheese fit on a slice of pizza? Well, we only measure one of these two things in square inches, and of course that would be area. So number 4 should be there. For 5, how many times does a horse go around a horse walker to walk 1 mile? We're talking about the distance around a circle, around the horse walker that the horse is walking. So we'd want to know the circumference of that area. 6 says how many feet are traveled by a person riding once around a merry-go-round? Riding once around a merry-go-round has nothing to do with the inside, the center area of it. So that's going to be circumference also. 7, how much room is there to spread frosting on a cookie? Well, we definitely want to cover the whole cookie, the whole surface of the cookie. So we'd be talking about area. And 8, how far does a unicycle move when the wheel makes 5 full rotations? We already talked about that. When wheels rotate, that circumference of the wheel is the distance that the wheel's traveling along the ground. Now, the 2 blanks below that ask for additional information needed to solve. So if we were actually trying to answer some of these questions for solving for area, so like this first one, how much fabric is needed for a round tablecloth? Well, of course, we would need the formula to calculate area, which we already have. Area is pi times the radius squared. We would need that. And being that this is our formula for it, we're going to have to know the radius of the table. So the radius or the diameter, because we could find that radius from the diameter. All right, it's going to be the same for circumference, except we'd use a different formula. Remember, circumference is pi times diameter. And in that case, again, we're going to need to know the radius or the diameter to solve for that. Okay, down at the bottom of the page, a circular lawn has a row of bricks around the edge. The diameter, and we've got a nice picture here to help us visualize this. The diameter of the lawn is about 40 feet. I'm going to go ahead and add that to the diagram here. Diameter, remember, goes all the way across, and it says that's about 40 feet. Which is the best estimate for the amount of grass in the lawn? They even color coded it for us. So we're talking about all the grass here in the lawn. We're talking about the surface area of this lawn, how much grass it contains. So we're going to need to use that formula for area. Remember, area is, and since we're talking about, we're estimating, we're just going to use 3.14 times the squared radius. Okay, we need the radius here. If our diameter is 40 feet, our radius is going to be half of that. So we're going to have a radius of 20 feet. That's what we need to start doing. We need to square our radius. Remember, that's 20 times 20. So we'll multiply 20 times 20, times 3.14. Now that's going to give an area of about 1,256. And remember, we're talking about area. Area is measured in square units, and in this case, it's square feet. And that's going to be important as we look at our answer choices, because I see two numbers that are close to our answer. One is in feet and one is in square feet. And since we're doing area, we have to measure that in square feet. For the second one, we're looking for the best estimate for the total length of the bricks. Remember, the bricks were surrounding the lawn. So the total length of the bricks all the way around the brick edge here is going to be the circumference. And circumference, since we're estimating, is 3.14 times the diameter. That's 3.14 times 40. So our circumference is 125.6. Circumference is just a distance. It's just a distance in a circle. So our distance is measured in feet, not square feet. And that gives us an answer of A. All right, on the back of your sheet is a little more practice and review with this. You're given the circumference of the circle and asked to find the radius and the area. So let's do one of these together just to get you started, and then I would like you to do the rest. So our circumference is pi times diameter. It tells us our circumference is 40 times pi centimeters, or 40 pi centimeters. All right. Now remember, our circumference is found by taking pi times the diameter. So right here in our circumference, because they gave the answer in terms of pi, because they're saying circumference equals 40 pi, we know we have pi here. That means this is our diameter. So if our diameter is 40, that makes our, and I would go ahead and add this to the picture here. The diameter is 40 centimeters. That means our radius is going to be half of that, or 20 centimeters. And then we just need to use our formula for area. So we're going to change course here. We use circumference first. Now we're going to use our formula for area, pi times radius squared. And we're going to multiply. Actually, I think we just had a radius of 20 on one of the last problems we did. So it has the same area as what we were talking about with the lawn. We would take pi, or we can round that to 3.14, times our radius squared. That's 20 times 20. So our area for the circle is 1,256. Remember our measurement unit for area, it's square units. We use centimeters in this example, so square centimeters would be the best way to label that. All right, continue with the rest of the practice, please. Finish up the problems on the back of your handout. And this, again, is going to wrap up Unit 3. We're going to have a couple of days of review next week, and then we'll be ready for a quiz and moving on to Unit 4. Everyone have a great day.